Welcome. In this video, we'll be taking a look at how to solve word problems using linear functions. So let's take a look at number 1 as an example. So number 1 says, Joe will drive to Memphis. Suppose that the distance to his destination is a linear function of his driving time in minutes. When graphed, the function gives a line with a slope of -0.9. Joe has 70 miles to his destination after 23 minutes of driving. How many miles will he have to his destination after 43 minutes of driving? To me, this is the really cool thing about math. And the idea is, what I find cool is that knowing something about minutes can somehow tell you something about miles. So, to me, that's kind of cool. Just knowing information about one thing can actually tell you about another. So, they give you this graph, and I've reproduced it. And notice that on the x-axis we have minutes, so that means all of my x values are going to be minutes. On the y-axis we have miles, and so this 70 represents miles. And what they tell us right off the bat is that after 23 minutes of driving, he has 70 miles to go. So that means this point right here in the graph has coordinates 23, 70. What's our goal in this problem? Well, you can find the goal in this last sentence. And so I've summarized it by basically saying that our goal is to find the number of miles after 43 minutes of driving. In other words, if we graph this out, our goal is to figure out after 43 minutes of driving, how many miles is that going to correspond to? We already know 23 minutes corresponds to 70 miles. So our goal is to figure out how many miles 43 minutes corresponds to. So they actually use a key word in the word problem itself, and that key word is linear. So they say that the distance to his destination is a linear function of his driving time. There's a root word in there that you're all familiar with, which is line. And we all know how to write an equation for a line at this point. If not, go back to my video on writing the equation of a line before you go any further. So the first step in this process is to take the information that we're given and write an equation for a line. So I've begun that process. So the first thing we're going to do is, of course, write out y equals mx plus b. And in this problem, they actually give us the slope as -0.9. So I've already written that m equals -0.9. Next thing is to plug that slope in. So that gives us y equals -0.9x plus b. And then the third step is to actually find the b value. So to find the b value, I'm going to plug in my x and y coordinate that they gave me, this 2370 point. I'm going to plug 23 in for x and 70 in for y. And then in this problem, they're going to give you a calculator. So we've got 0.9 times 23 is 20.7, and I know that should be negative. So we've got -20.7 plus b. So if I add 20.7 to both sides, that would give me 90.7 equals b. So now I have my equation. If I plug everything in, I've got y equals -0.9x plus 90.7. So what we've just figured out is if I know any information, if I know any x value, I can plug it in and figure out its matching y value. Well, that's exactly what I want to do here. Because what I wanted to figure out was the number of miles. Well, miles is my y, those are my y values. So I'm trying to figure out a y value. But what they give me is an x value. So now all I'm going to do is plug 43 in for x in my equation, do a little math here and I should be done. So step 2 in the process is to plug in the known x value. So in our case, and what I mean by known x value is the known x value that matches up with the y value you're seeking. So for us, that's going to be x equals 43. So we've got y equals negative 0.9x plus 90.7. If I plug in that 43 for x, let's see what we come up with. So we've got 0.9 times 43. Okay, again, I know that that should be negative. So and then I'm going to add 90.7 to that answer. And we end up with 52. And again, what that means is that we have 52 miles to go after 43 minutes. Now let's see if that makes some sense. Well, we knew after 23 minutes we had 70 miles to go. So after 43 minutes, I know that that should be fewer miles to go. So 52 seems pretty reasonable to me. Okay. I'm not going to have you try number 2 in this case, simply because the graph isn't provided here, and I think it would be very difficult to see.